Thank you
All
so
right.
much for joining us, and I'll hand over to you.
Fantastic. So I suppose you want to actually see my talk, and you're seeing my desktop, so this is better, right?
Yeah, that's perfect. Thank you.
Okay, that's great. Okay, so thanks very much for having me here. I'm really sorry that I missed this morning because it sounded like there was a lot of relevant discussion in the panels and the breakouts. I did make it yesterday morning. I also didn't make it yesterday evening. Lots of strange things are happening in the world right now. And actually, I loved the emphasis, not only that really the way people are really thinking about what the body means to intelligence, but also that they're thinking about like, what does this mean for applications and in the real world? So I'm going to definitely try to get there, but I have so many slides. So please do tell me if I only have sort of 5 minutes left. Give me a 5-minute warning. Is that okay, Josie?
Perfect, will do.
Okay. So of course now I have to convince the program to listen to me. Okay, there we go. Yeah, I don't know why it makes me do that. All right, so I'm going to talk first about embodied semantics, and then I'm going to talk about an alternative theory, which is mimetic semantics. And then I'm going to talk about how these kind of come together and apply to AI. And then at the end, if I have time, I'll talk a little bit about consciousness and why humans are different. Okay, so again, here we go. So why is it that humans have all the best toys? This is where I am right now, but I'm not outside. I'm in the hotel room showing you these slides. And one of the questions that people ask a lot is whether a shared embodiment is necessary to really have AI. Okay, so there's at least 2 theses here. One of them is that embodiment is necessary for semantic understanding of language, because otherwise we don't have shared experience. So, you know, little babies spend a long time figuring out things like what a path is, right? You know, how do you get from one place to the next? And then we take all that we learned as babies and we use it to try to understand things we only get to do once, like life or career or things like that. So that's one theory that's like had a huge influence on humanoid robotics. The other theory I want to bring to this is something called mimetics, which is the idea that all of culture, including language, itself evolves. It's not just that we've evolved to do it, but that the language evolves, it sort of co-evolves with us so that we can learn it. Some people like Susan Blackmore even talk about consciousness being like a virus that's taken over our bodies and is misdirecting our attention. So she's a Buddhist, or she was when she wrote this book. I'm not sure about her current status. And she really, really thought that it was the viral thing that brought us down, all this consciousness. So, but anyway, a lot of people who don't necessarily go that far would still say that there's this idea that maybe we don't know what we're talking about entirely, but selective unintended processes have brought us to be smarter by helping us evolve language and making us smarter. Okay, so I want to back up a little bit and say, well, going back to that question about why we're the only ones with electric scooters in Paris. And there's been a lot of theories over the years. So for example, we're the only species that can use tools, and so therefore we're the only ones who get built culture. We're the only ones with a self-concept. We're the only ones with moral sensibility. Maybe we're the only ones with culture. We're the only ones who can teach each other. So we have some special relationship with the next generation. And then finally, maybe it's just language. Well, many of you may know that science has shown that lots of animals can learn to use tools, or they use them all the time. And we've also been able to show that animals do have self-concepts by figuring out really clever tests like the mirror test. It's not the only one that demonstrates that the animal seems aware of the concept of itself and can reflect on what is being seen in the mirror. And not only chimpanzees, a few other species, not loads. With respect to moral sensibility, there's some phenomenal stuff with monkeys being offended if one monkey gets paid more for the same job. So one is getting cucumber, the other one's getting grapes. And for monkeys, that's like silver versus gold. And so the one that's getting only the silver is really angry and starts throwing things and whatever. And similarly, anyone who has a dog knows that the dog acts guilty some of the time, right? So culture and teaching, I sort of skipped over culture, sorry about that. There also is a lot of evidence that species that, you have genetically identical species that have different sets of behaviors just if they're on different sides of a river. So different troops are expressing different capacities. So that's been taken as evidence of culture. And then teaching, this was for a long time, we didn't have evidence that animals would pay a cost to educate another animal. And then two things came out like around the same time. I forget exactly when, the early noughts, I think. One was Nigel Franks showing that the ants would wait around and teach each other the way to a new nest until they had all agreed it was a good nest. And then the ants just go back and carry each other because ants are really strong and it's a lot faster. But they were paying a cost at the beginning to try to bring along a group that could consider and ponder whether that was a good nest. And similarly, Alex Thornton figured out that meerkats were catching scorpions and then biting the tails off so that they couldn't sting the pups, and then letting the pups learn how to catch a scorpion. So they're paying this extra cost of time even for bringing food anyway. You're paying a cost to feed a baby, but in this case, you're paying a cost to educate the baby how to catch its own scorpions. So the one thing that's left that's different is language. So that's going to be the main focus of this talk. But going back to AI, well, sort of AI is a big focus of this talk too. Since the 1950s, a lot of the funding, especially in the United States, was based on this promise that we would be able to get machine translation. And for a really long time, we didn't have it. It's because we were trying to do something with logic that didn't work. The idea was that we would solve syntax. We'd know, like, I'm in France now, so that the adjectives come after the nouns or whatever. So we'd figure out a way to do a simple transformation on the syntax, and then we just look up in a dictionary the local words. It's not how language works. Different languages have actually different concepts, and so you can't do anything like this, and it didn't work at all. And interestingly, a lot of it was because Americans didn't trust anyone who spoke Russian, and so they didn't want people to know Russian. They wanted machines to translate Russian for them. By the 1980s, people figured out that this wasn't working too well, and this new theory sort of came up, which is maybe we need grounding. We need to have a connection between the words and this experience. So this comes back to the embodiment that I talked to you about before. So that's like Steve Harnett and Rod Brooks. And arguably until now, this is one of the things that people have thought, maybe we need robots for language. Now, of course, now we do have machine translation that works pretty well. It doesn't work anything like what I just described. It's much more about, well, we'll show a little bit about it, but it's basically looking at patterns of use and just saying, I bet you're going to do the same thing. So coming back to embodiment for semantics, as I mentioned, that's double, well, I'll go back and do it. The idea was that NLP had somehow failed, or AI was failing, and I already told you this about life and career, and that was how we were funding humanoid robotics. And I was on one of those projects. So this is me back in 1993. I still wasn't that young at that time, but obviously I'm younger than I was now. And I was at MIT, and I was on this project that was supposed to build a humanoid robot named Cog. All right, so the idea from the original proposal, which was actually a funding proposal, was that we would, by 1997, have solved intelligence. But if you look at the things we were trying to do here, a lot of these things have been done now, right? A lot of this is sort of done, except, well, actually, this is the sound stuff, so what you usually think of as language. But a lot of these other things, like visual imagery leading to mental rehearsal, or body-based metaphors, like I just sort of described, those are things not really entirely there. Getting to symbolization, we have something like imagination. And we've heard a lot about that already at this meeting, that you can do these kind of rehearsals and pre-planning. But whether that really is giving you symbolization, that's useful cognitively the way we expect in humans, it's not as clear. And my personal favorite is that multiple drafts, which is a theory of consciousness due to Dan Dunnett, was just supposed to emerge. We weren't going to write that. It was just going to come for free once we got around the middle of this project here. Okay, so the problem with all this is there's basically no positive evidence. It's been decades now. And as I said, language improves basically when you have more of it. And a bit with some machine learning algorithms, but mostly it was computation and data. So let's go on and have a look at the mimetic semantics side. So the idea here is that you use large corpuses to try to get information. You look for sort of pattern recognition across a whole lot of texts. And the whole basic idea is that the more one word is used like another word, they mean the same thing. Now, this may sound completely circuitous, and it kind of is, but give me some time here and I'll try to convince you that this might work up to a point, but then guess what? We're going to come back and say, well, maybe you do need embodiment in a little while, but there's a while where we're going to go through this stuff. Okay, so mathematically, this theory is exactly the way that web pages are indexed and used too. And people back when we were first coming up with this in the 90s didn't realize that, but Willow is one of the people in his dissertation that showed that. Okay, so the older theory of language, this is 1997, Terence Deacon's famous book, The Symbolic Species. There was this idea, I'm sorry about my bad drawings, one day I'll improve on these drawings, but that's supposed to be a chair on the left, and then there's a table, and then there's running. And the reason I put running in there is it's a bit of a joke because actually people have trouble with verbs. Babies don't learn verbs very well. But anyway, and then there's even more of a joke that I then say, oh yeah, you've somehow learned the concept for chair, table, justice, phobia, and run. And then then the idea was that after you've learned these labels, so you hear your parents saying a word and you connect it to your lived experience, then you start learning relationships between these things and you start being able to substitute. So I think people thought that because little kids take a long time, for a long time, they use 10 words for basically everything. And then there's sort of this explosion. So I think that's why they thought this was going on. Well, what I noticed at some point in the past, I think I first started talking about this in about 2000, was if the machine learning, if the machine learning or the human learning of language was happening in parallel. So I hope you guys have heard some talks about like how we learn vision, how you connect your retina back to your V1 and, how the brain self-organizes. It's such cool stuff. So I already knew about that from my master's degree in AI. And I thought, wow, if language is the same, if there's some way that you can learn all the connections, just like you have to learn the connections of your retina back into your V1, if you could learn the connections between the words, then you would have a much easier learning job. It would make a lot more sense. Then if you are presumably still doing the Leckhoff and Johnson thing, you really are learning concepts for like dog and mom and table and whatever. And then you just have to tie in a few of those concepts rather than tying in all of them. And then you get access to all that stuff that was out there that you were learning automatically just by hearing adults talk around you. So that was my idea, and it got published finally in 2008 after many tries. So again, it's not like I was the first person to think of this. In fact, I still find it sort of unintuitive, but smarter people than me, like Wittgenstein and Quine, had been talking about it for a long time. Again, they were saying, what can semantics possibly be? Maybe words mean only how they're used, and there's no more to it. These kind of reductionist things drive people crazy. It's like the hard problem. They say, oh, it can't be that easy. There must be a harder problem somewhere. But it's surprising when you're a roboticist and you can actually build things. Quite often you've realized, oh, right, it does make sense. It does make sense to think about things this way. So I'm hoping you're going to get that feeling from this talk. Okay, so the idea is that you're using words sort of to index other words. So here I'm trying to claim that hat and obscure are just two words that you're looking to see, you're using kind of as an index into your language to meaning, and you're saying, what can these other words? So the ones you're trying to understand the meaning of are scholar, paper, and rock. And part of that meaning is how frequently those words co-occur next to hat and obscure. So the idea here is that scholars are kind of more frequently called obscure than papers are. And although papers are used to obscure things sometimes, so they do occur sometimes near each other. And that rocks are more like hats. Maybe I should have had paper the other way. I should really look up the vectors for this because this is knowable and I just haven't done that. But anyway, I hope you get the idea. This is only 2 dimensions. In reality, we would be using all the words, or at least all the frequent words, to kind of index into what all the other words are meaning. But anyway, you can see how you draw a vector. It's like, okay, I saw a hat, 30 times with rock, and I saw it 20 times with obscure, rock 20 times with obscure. And so that's why that vector is kind of angling it that way. And so the idea is that cosine, just the distance between the angles, shows you how close 2 words are in meaning. And of course, this isn't only happening in 2 dimensions, it's happening in enormous numbers of dimensions, but this is all I can draw on a piece of paper. Interestingly, if you do have lots and lots of dimensions and then you compress it down, you actually enhance the signal. Now, some people, especially when they're calling the signal bias, say, oh, it exaggerates the bias. But I don't think that's the good definition of enhancement. I think it's more that you're just detecting the regularities. Compression is a good way to detect regularities. So back in the 90s, people were doing things like, this is a projection of a 75-dimensional space onto 2 dimensions, and they'd kind of sit around and look at the pictures and talks like this and say, oh, look, you know, brother and sister are kind of similar to each other, and king and queen aren't too far from each other. But more importantly, you're not just like eyeballing the projection into 2 dimensions, you're measuring the cosines. And from that, we were able to see that, our intuitions about semantics were matched up with reaction time studies. Now, reaction time study is basically how fast can you push a button? And so we knew that if you've seen a word that means something like the word you've just seen, then you can push a button faster that says, yeah, that's a word I know. So that's called priming. And so we're using reaction times and semantic priming to check what human semantics are. And then it turned out that these machine semantics are like 75% correlated, which is pretty good given how many words there are. Okay, that was the way, that was then, this is now. So now I'm going to go to actually my most cited paper. It's from 2017. And it's mostly known because we showed that AI was sexist and racist. But what I'm going to show you is what we were really talking about, or at least what I was really talking about. I think my colleagues, actually, my co-authors, were very concerned with AI fairness, but I was interested in semantics. Okay, and so that's what the paper's called. It was categorized as cognitive science by the journal Science. Semantics derived automatically from language corpora contain human-like biases. So here, once again, we've got the human-like biases. It's like some of the most cited papers, it's a huge effect in psychology, that it's much easier to push. If you get told that your job is to push a button, if you see either one button for either a boy's name and a math term, or a girl's name and a reading term, that should be no harder or easier than doing it for boys in reading and girls in math. But we don't live in a fair world. And in fact, people find it, or at least found it in the 1990s, to be easier to push boys with math and girls with reading than the other way around. Okay, so the idea is that associated concepts are easier to pair, and then the differential reaction time of how fast you can do that button pushing is a measure for how much bias you have. Now, people hated these results because it showed we were all sexist and racist, and but only at the implicit level. This is a measure of not how you would think about it, not what you would choose to do, but rather just how your brain works as a piece of hardware, well, wetware. Okay, so in saying that I thought machine corpora were going to show the same kinds of biases as humans were showing, I was actually making a couple different hypotheses underlying that. Okay, so one is that AI built with machine learning contains our implicit biases. So again, that was the one that made headlines worldwide. But what I thought was interesting was it showed that implicit biases are a part of ordinary semantics. It's there in the language. All right. And we used just standard, we didn't create the horribly biased. We used two different representations of word embedding. So there's different things you can do about like how wide of a window around the word are you keeping track of, and how do you multiply, discount how far away it is. So we used one that was Google's Word2Vec and one that was Stanford's, which was called Glove. And then we also used two different corpora. So the Stanford had this incredibly large corpus, which was really useful because it had 2.2 million unique words and 840 occurrences of those words, right? I'm sorry, 840 billion occurrences of those 2.2 million words. The 2.2 million turned out to be important because the psychologists whose work we were replicating had used some pretty obscure words. So we needed that large corpus. But we also used Google News, and we got almost identical results for both of these. The only thing was, as I said, it was hard to find some of the words in Google News, and I'll mention which words those were in a minute. But anyway, we didn't do anything weird. This was stuff that people are using in products every day. Okay, so again, before you talk about sexism and racism, it's good to talk about something people are a little bit less touchy about. And so Greenwald et al., who were the people who invented the implicit bias test, the first thing they tried was like things like flowers or things like insects. and whether it was easier to match up flower names with pleasant things and insect names with unpleasant things, or the other way around. And I want to show you the findings here. The D score means that you have a standard deviation around like how fast you were able to push that button. So the means between the flowers and pleasant and the insects and unpleasant versus the flowers with unpleasant and the insects with pleasant, the means of those is more than one standard deviation. So that's what this D score is. It's in terms of standard deviations. So that's incredible. That's a huge effect. So that's and then the p-values are just telling you how certain you are that those are two different distributions. And surprise, surprise, you're very certain that those are two different distributions since they're so far apart from each other. Okay, so it doesn't end there. It wouldn't have gotten the headlines if it did end there. I still think, back to our embodiment and mimetic story, that is a huge result. The flowers and the insects thing that you find that in AI, huge, but we'll get to that in a minute. Unfortunately, it also was true with European American names versus African American names. And so nobody wants to know this, but you can go look it up online. You can do the stuff yourself. And we all have levels of implicit bias in us, including people who are African American, incidentally, although they have lower levels of this particular implicit bias. Similarly with gender, this is the pairing of career versus domestic terms, or arts versus sciences. So every single paper that had been published with a general audience, because we only had the whole internet, we couldn't say like, oh, what do a particular subset like women think? We couldn't match those ones up. But everything that was for an entire general audience and it was using words, we checked every one of them. And we found them. But not only did we get these visceral facts, like things like the insects are unpleasant, out of the internet, we also got actual truth. And this is not something I expected at all. I wouldn't even have looked for it, but Arvin Narayanan had the idea. He was up for 10 years. So I think we were all kind of shocked by how strong these results were. So what he did is said, let's take these word embeddings that we've shown now match up with our sexism, the implicit biases that the psychologists have been detecting, and let's compare them to things that we know are true. So this was a 2017 paper, but we used the word embeddings were created in 2016, and we're comparing it to 2015 US labor statistics. And so each of the dots on the left chart there are the name of a job. And unfortunately, some of the jobs had 2-word names, and that didn't work with the word embeddings. And that's why you have some outliers there. We just sort of left off the first word. But nevertheless, even though we had to be sloppy like that, like again, the row, which means how correlated are they? 90%, unbelievable. And then over on the right, the last year that we had the names, people's actual names in the census, so we could see for any particular name, what proportion of people that had that name were male or female. Okay, it's only an 84 row, but that's again huge for psychology. And I would call this a prediction. So if you could go out and find out what the 2016 name, like how many people were named Alex were male or female, and how many that were Chris, and whatever, then I would predict that we'd get even higher than 90%, because those are by and large single barrel words. All right. So yes, we can now easily communicate facets of meaning we don't even have a conscious access to artificial intelligence. We can bring over not only the semantics that helps you do a web search, like for what you're actually looking for, but also the bad stuff you didn't even know you had. Okay. So on the other hand, what does that mean? What does that mean with respect to AI? Does that mean AI is already a person? Okay, so now I'm getting on to the third part, and I hope that whoever just chatted to me isn't telling me I have 5 minutes left. Please do that by audio. Let's see. Yeah, so my answer to this is robots aren't people, even if you make them look like people. And the whole way I got into AI ethics is because I was in a lab, I showed you that picture earlier, where all these robots were there. And the other 3 worked, okay? The human looking robot at that time did not work at all. Eventually it kind of worked. But I mean, it's academia, they all kind of worked, right? But anyway, the point was nobody stopped by and said, oh my gosh, it's terrible. That robot that's holding the tin can is over in the corner. But lots of people just walked up to me while I was sitting there trying to program the robot and said, oh, it'd be unethical to unplug that robot. And I was like, it's not plugged in. And they'd be like, well, if you plugged it in. And I was like, well, it doesn't work. They didn't know what they were talking about. It's not a person, all right? People, though, really, really want AI that they owe obligations to, that they can fall in love with, et cetera. They want equals that they can buy, that they can turn off and on. It's just not right, okay? But anyway, I'm going to skip the psychology talk here because I'm more interested in the semantics talk. Yeah, I already said something about this. People would just, we're talking not only, it wasn't only about how they talked about cog, but it was also how people expected that AI was going to take over the entire world and that we would become cockroaches or something. So I worked with another philosopher I knew, Phil Keim, and we wrote a paper where we said, this is partly because we don't know what it is to be human. We don't get what it is that makes us care about things. And actually, maybe if we had more artificial intelligence around, we'd understand it better. So actually, that's not what this paragraph says. This is saying that the real dangers of artificial intelligence are there, that you have a problem with them, just like you have a problem with like sewer systems and electric systems, right? They could be misused either through carelessness or malevolence, and then a lot of people could be in trouble. But that's not like, taking over the world. That's people manipulating your election or something. Okay, so this is still something that we have been talking about ever since, is that it's something that people use. That's what the A in AI stands for. It's an artifact. Anyway, we said that, as I said, ethical instincts and ethics itself is rooted in identity and identification. We tend to understand how other people operate by thinking about ourselves. And then we mistakenly think that language and math and stuff like that is the core of humanity, because that discriminates us from animals and we want to eat the animals, right? But once we've got, and so we said in our paper, once we have an empirical experience of AI, hopefully we'll get less confused and we'll start understanding what it really means to be human. And that might even help us do a better job of treating other humans well. Unfortunately, we were wrong. This is some students I had at University of Bath. And they, though they built the robot themselves, they're saying that they love it. Now, they did then dismantle. Actually, this robot won a prize, and so it didn't get dismantled for a year. But the other students all had to dismantle their robots so that the next students could do it. So you can say you love it, but people will still take it apart. But anyway, this kind of confusion leads also into some much more serious things. So people are talking about, can we make AI that would be a legal person? And some people do that, just like I said, because they want to like own someone and then say, oh, that's my partner. But other people are doing it because they're trying to get out of liability for their driverless cars or something like that. And what they don't understand is there's no way to apply justice to something that's not a person, right? Because justice isn't just about like, getting your money back. If someone stole it, the police go and get your money back for you. No, that was a lot of trouble. It took time. It took resources of the community for the police to chase the other person. You need to dissuade people. You don't just get the exact amount of money back. You throw them in jail for a while for doing this bad thing. Why would it matter to a computer if it's put in jail, right? So any system that we build, well, that's safe and secure and accountable, that we can tell whether people put it together well, it's probably going to be modular, and it's not going to suffer from isolation or loss in the way that any social animal, like, a sheep or something, would care more than any system that we're going to build. So no penalty of law that we use against the artifact, including things like shell companies. So we can think about the structures we already make. In general, law works well against companies if somebody wants that company to exist. If the people who are in charge of it are invested in it persisting, then we can persuade them to try to do the right thing, so we let the company continue to function. But there's these other kind of companies that are set up deliberately to go bankrupt. And this is a major source of corruption in the world right now, right? So money laundering through real estate deals, you can't imagine any corrupt people doing real estate deals. Anyway, the humans are the accountable moral agents. And if no human cares or at least the humans that care don't have any power, then justice falls apart. So even though that other paper came out in 2017, I kind of think this one is at least as important. This was something I wrote with the other two people are actually law professors, and they're super smart. They're amazing people at Legal Personality. And so this came out, and I will mention that it's only humans can only hold other humans accountable. Our society is set up that way. Other species have their own ways. You know, the chickens peck each other. We don't care, right? It's not a part of our thing, but the chickens figure out what the pecking order is. And monkeys and apes also do things that kind of imply that they're holding even senior animals to account, that the other ones will kind of, if there's something going wrong, may stand up to them collectively. So cichlids are kind of fish. I'm not going to go into that. Some people, when I say all this, think that I am a humanist and like sexist or something. And these are pictures I took. These are my own pictures, right? I love robots. I really enjoy them, right? But they're not people, right? There's something we build. We get to design it. There's no one thing it is to be a robot. They could have any number of arms, you know, CPUs, locations. It's completely authored. It's like a novel, not like a child, right? Someone has full responsibility for designing it and making it and owning it and operating it. And so we will not, as I mentioned, build well-designed, safe, modular commercial products that have coherent notions of things like pain or aversion to constraint. I mean, systemic. Sure, you can put an index, you know, like an integer in there and say, oh, it's happy or not, right? I have a lot of systems for doing that. It's useful, it's fun, but it's not the same as actually the systemic aversion you have to being constrained or being isolated. All right, so yeah, artifacts aren't animals. So yeah, back in the 1990s, I thought, look, embodiment and memetics are both cognitively minimalist strategies. So compared to the GoFi that was mentioned by the first speaker yesterday, the good old-fashioned artificial intelligence, there's no assumption that meaning is based on logic or something, and there's no assumed complete understanding of the universe, you know, or even your room to get around it. But what you have is basically this idea that large corpus linguistics is saying there's just another module that's plugged into the rest of the system, but the rest of the system matters a lot. Okay, yeah, so yeah, and I already said that about that. So I want to point, but coming back to, is it actually a person? This paper I wrote that finally got published in 2008, these lines where you're drawing between your actual experience of the reality and these words that you've heard, that's what I called understanding, right? It was that connection. So having perfect semantics wasn't really understanding. It was being able to play the game that is language. But understanding was going, oh, this is what it like, you know, the first time you've fallen in love, really, you know, it's like, oh, I've read about it a lot, but now I get it. And you can't really describe all those visceral feelings you have, right? Or if if you've lost a home or something, you know, or even just like what you ate for lunch, it's very hard to describe that in any kind of detail. But you can evoke it in another human that's had a similar experience, right? By saying, oh, it tasted like an apple. And they go, oh yeah, I know what an apple tastes like, right? That's something you can't communicate. So we're never going to build something out of entirely different, stuff. So yes, we can clone humans, and that's considered immoral and illegal all over the world. But you cannot bring something into being to be another person. That's not okay. However, if we're talking about something we're building out of plastic or metal or something, then it's not going to share our viscera. You know, cows share our viscera, and quite a lot of people think it's okay to eat cows, right? Chimpanzees are so much like us, and they can learn language to an extent, but they can't get there all the way. They never just turn into a person, although you can have conversations, and the story of Nimchinsky is devastatingly depressing. So just to get to the end, I still have more than 5 minutes. This is great. Okay. Why do humans have all the best toys? I don't think it's about consciousness. Now, NBD means no big deal. And again, this is a paper I wrote before, and I'm working on a book now that fleshes a lot of the stuff out. This paper was kind of, quick and dirty. But basically, many species have the capacity to make plans. It's something that we do. This is what explicit knowledge, remember I said that the implicit biases, that's like the bootstrapping, those implicit biases reflected our lived experience. You just counted how often did you see a woman that was a programmer versus how often did you see a man that was a programmer, right? So it's just statistics. It's just being gathered by your brain. That's implicit. Explicit is when you're trying to construct a new plan. So the most basic thing is navigating. And so we see, well, actually birds and mammals sort of have this, I don't know if reptiles really have it, but it seems especially something that mammals were into, but birds have an analog. Anyway, it's another argument I have with Marie Shanahan sometimes. The point is that you flesh out and that are basically at a very high level of abstraction. So you have this very high level of abstraction that you can make quick changes in, and that is rooted in the slower, longer term learning that you did that was your implicit learning. So, right, so all these plans are based on memories of things like, what was your visceral reward for getting to that particular location? Why do you want to be there at all? And simulation of likely outcomes of the things that you've done. You know, when I walk, I tend to go at the speed, whatever. So humans are also able to use this planning system to communicate. Actually, probably other species intentionally communicate sometimes. In fact, we've seen in non-human primates that sometimes they withhold information from each other. So they also seem to have something going on that's conscious about, do I say something or not? But what they get to say is much more limited than what we do. We have more plasticity. So language allows us to share the most useful concepts. When you've heard a word and you don't know what that word is, I might have used a few weird words here. You can go back and try to figure it out. You can listen to it, you can try to use it, and then you might get a really useful concept that other scientists have found out before were good concepts. So that's what we do with language. So then why are humans special? Where did we get language? And this is my personal theory that I've published a few times, and this is the slightly older version. I'll get to the newer version in a minute. Basically, humans are the only primate species capable of precise vocal imitation. You know, birds can do that, elephants can do that, seals can do that, weird animals can do that. It's not that common, but it's a lot more common than language to be able to do that. So why does that matter? You've now got like 2 seconds, a 2-second sequence with a huge amount of information in it. The pitch, the volume, the timbre, the precise temporal subparts. And so all that information gives you a way to encode what's important, but also kind of hack around with and modify other parts. All right. And for those of you who've actually done any genetic algorithms or thought about evolution much, I hope that sounds familiar. Now we're talking about something, the first billion years or so of biological evolution was getting to the point where you had something like DNA or RNA that could really replicate itself. So it could encode information, but also allow this kind of mutation. And so this is basically called the second replicator theory. It's not only my theory. The only thing that I'm adding in here is pointing out that we're the only species that are doing it. So the idea is that language itself evolves to be more learnable and more explicit. As I said, this is called dual replicator theory. So human culture and human biology are both evolving together. And so we got better and better at being able to hear these little differences, to speak quickly. You know, we can look through our history and see where our biological evolution seems to have been subject to the fact that we had advantages if we could talk better. Okay. Even within a genome, like an ordinary genome, there is hierarchical representations. And I'm still waiting for the day that sort of deep learning hits genetic algorithms, because I think it's been under-recognized how much biological evolution people see things. Like, for example, there's parts of your genome that flag up that this is a good place to innovate. In humans, a lot of that is in the central nervous system, which is why some of us think differently, right? So language allows you to do that too. There's things that are rigid, and then there's things that are easy to fix. All right. So the idea is, oh, this is just a side thing, communication and sociality. The more you can communicate, the more you're able to exploit social strategies and come up with ways to create public goods. And so if we had a system that evolved to constantly improve our communication, and then you would expect us to have more and more and more public goods. And this is basically a theoretical biology paper that says that, which I think hasn't been adequately applied into thinking about the evolution of language and the evolution of human culture. So this is going back to my older theory. I thought the thing that we had and that the other species didn't have was we had this temporal imitation, and then we also had second order representation. So I thought originally that it was because non-human primates, the monkeys and apes, well, all of us and human primates, think a lot about how others relate to each other because we have very complex societies. However, I've got a simplified version of this theory now anyway, which is just that we had the biggest brains. So like the parrots and things are flying around, they just couldn't remember as much stuff as we did. Anyway, maybe it's something as simple as that, which is how we bootstrap the second replicator system and then turn it into really a very different set of solutions. So again, all the great apes have culture, and we're pre-adapted to remember lots of stuff about each other, about how we get food and things like that. And then the second replicator system takes off and we can do even more. So that's my theory. So in summary, embodiment is the basis of what it is meaningful and worth communicating for us, right? It's also the basis of our justice. So embodiment is still doing a lot of things that you're not going to get just by, happening to shape your robot like a person. But nevertheless, semantics can be communicated mimetically. So can preferences in music. It's not that the Amazon computers prefer the same music you do, but they can sort of do vicarious empathy by saying you're going to like the same music as that other person who liked almost all the same records as you did, right? So we can transmit that stuff in computers. It is probably part of how our entire language system evolved, but it's not sufficient. So necessary, but not sufficient. Okay, so thank you. And this is some of my co-authors that I just mentioned.
Thank you so much, Joanna, and also perfectly on time as well. That was a really fascinating talk and a lot to think about. So I was just wondering, so you said in terms of we shouldn't think of robots as equal. For those of us developing robots, is there a good way of thinking from a robotics perspective of how we should think of robots, if not our equals?
Well, yeah, as stuff we've built. I mean, it's tragic, but the truth is that there are artifacts that we consider to be worth more than human life, right? We invest enormous amounts of money in very fancy museums while letting people starve, right? Yeah. So it doesn't mean that it's not worth as much as a person. It's just that it isn't a person. And so what I'm saying isn't that don't think it doesn't, that your work has no value. It's that don't think that it's okay to design something and then to offload your responsibility to the thing you designed. That's the way we've coordinated our societies and how we maintain justice, is that the stuff that you do consciously and deliberately is your problem, right? That's what it means to be an adult human.
Yeah, and a question on the chat from Langdon, does Alexa Google think it is a person? So I guess from the other side, do robots or in these selves, virtual presence, see themselves as a person?
Right. It's not clear that all people see themselves as people, right? I mean, there's a huge range of what it is to see yourself as a person. And as you develop, as you continue aging, that what you think it is to be a person will keep changing too. I mean, it's shocking. I remember when I was 25 and I had flatmates who are 23 and they didn't believe that there was any more adulting to do. But trust me, every year you say, really? I used to think that, So your concepts do keep changing. But having said that, no, I mean, I don't know. Again, it depends what you mean by even thinks in this context. So it could quite possibly be that like, let's talk about Google rather than Alexa. So Google has indexes, it indexes everything, including itself, right? So you could say it has self-knowledge because you can go into Google's web pages and see, you can Google, right? It has the kind of self-knowledge, but like I said, I don't consider that to be as big a deal as the entire gestalt of our lived experience.
We're getting some very interesting questions on the chat, so I'll read them out and we can discuss them a little bit more. One from Famia: what about robots imitating humans? Does that bring the gap between, even though, as you say, we're different, it doesn't matter that we're different, but how there is still a scale, or there is some kind of continuity between this divide?
Do you think photographs are more like a person than paintings are?
it's the extent to which they capture them is quite interesting, or it gives you, it's come back to your discussion of shared understanding between people. It allows you to have a different embodied understanding of them. That's a very good analogy.
I guess you could, yeah, actually, when people first created photographs, other people were horrified by having people on their walls. And there's like some really great things. Actually, I'm in Paris, but I haven't got any time to go to a museum. But last time that I had time to go to a museum, I went to Musée d'Orsay. And there's like literally a room of all these early photographs that people could buy. And they're all covering their eyes because people didn't want to be watched by the photographs. So they're nude, they're like nude models, yet covering their eyes so they don't freak people out, so that you don't see, that people don't see you looking at them or something. I don't know. And so I think to some extent of how I defined understanding, then imitating might be, you might say, well, that's like, it's sort of like the having the sexist notions of program, of whether you're programming. It is a replication of human culture, but it's a very shallow level of replication, and it's still very shallow. I mean, I used to be a big part of this. Why do you think I did a PhD on like, humanoid robots? I thought, wow, models are useless. We can't have the simulations. We actually need robots because they experience physical space with us. And there's some truth to that. There is something about the physical space and navigating that, like I said, is essential to consciousness, or was for us to get to that. But at the same time, once you really start working on this stuff and you're looking at things like computer games, and you start realizing, or I know I was specifically working on RoboCup. So like the soccer stuff. Yeah. And it became evident that RoboCup that was in Simulation League was way more like playing soccer than, because I did play soccer, than the robots, because the robots at that time could basically do nothing, and it was such a tiny fragment of the strategy that you had as a human running around on the field. So I've started to realize that robots are also simulations, nothing like the sensory information that we're getting on, like all these little hairs on my arm and everything else. Nothing like that is happening.
Yeah, no, that's really interesting. Actually, and touching on this difference between, so you kind of, what defines a human from their semantic perspective? Do you think we can extract those rules or some of those to also the physical perspective? Because there's things like memory, there's things like a temporal state or a dependency that we have in physical systems, as well as their semantic language understanding. Do you think there's similarities there in how we can analyze and understand the body as well as the brain?
Yeah. Well, one thing I haven't written up, it's just in a notebook somewhere, hopefully will make it into my book, is like, I had a PhD student, Yekaterina Nevikova, and she's great, but she was working really hard about we tend to think that getting people to anthropomorphize, to believe that the robots are people, is bad. And so she was trying to come up with non-anthropomorphic emotions. So she thought emotions were useful so that for communication or something. But she tried to come up with emotions that people didn't have, but that they still help them, create coherence for the robot's behavior and things like that. And as I thought about it more, again, this is going back to the sort of collapse and simplicity that, it's not clear to me that there's much more to like happiness and unhappiness than gaining in group and losing things, and anger and fear. Like, you could start thinking about like these very basic things we have to do as social animals that we really care about. And the most basic ones are depression and excitation, right? So it's basically go or no go. Is it time to withdraw, or is it time to take risks? And so I'm not sure if you can call them other things, but in a way, so what, to come back to your question, I guess in some ways it is bringing something a little bit closer to what it is to be a person. But the problem I'm worried about is the gap, the scale of the gap, and then the assumptions people are making, because again, we want so much to have this capacity to create life, but also, like I said, why, what is the control that's going on there? So that's
really fascinating. And actually, one final question before we move on to the panel speakers, about this definition of or how do we define or compare humans? Does that therefore mean that animals that aren't humans are then not conscious, or how do we describe things that aren't human?
No. That's what I was trying to say before I said that. I don't mean this sounds like in a bad way, but I'm perfectly happy to say both AI systems and animals are conscious, right?
Yeah.
Because they have both the explicit and the implicit. I mean, machine consciousness to the scale that any robot has a hand, any system that can plan has consciousness. But I don't think that's like as central as if you're using that part. So what interests me as a psychologist is why is it that some of our memories we have explicit access to? There's things we can talk, there's things we can control, and other things we can't, like whether we're blushing or like I said, there's implicit biases, things like that. We don't remember how we came to know what Nova Scotia meant, you know. There's all these things that are the bootstrapping that just came from some combination of our genetic heritage and all the stuff we've been exposed to. So that's what interests me, and I'm perfectly happy to call any kind of explicit planning capacity a form of consciousness. And there's lots of evidence that, like, if you compare like rats, unfortunately people do surgical things to rats, and you can show that it's very similar to explicit versus implicit memory in humans. That have sort of, then we don't tend to deliberately do surgery to the humans, but if they do have these memory deficits, we can replicate them in rats and show the separability of it. So I absolutely believe mammals, and like I said, it's decently plausible even, that given the way birds behave, that they also have this explicit implicit difference, and that they're making plans and that they're creating relationships, you know, deliberately. And I'm happy to call that deliberate.
Really, really fascinating, and really a lot to think about, especially in the light of everything else we talked. So thank you so much for your time and for your talk, and for joining us. It's really fantastic to have your insights and perspective. Thank you.
Well, thank you for inviting me. This is not what people remember that I do, but it is the stuff I care most about. So I'm really happy about your conference, and thanks for inviting me.
No, thank you. And hopefully you can join us a little bit for the panel discussion. So we next have
I'll stay a little while. I got another thing I have to do.
I'm sure you're very busy, but anytime you have,
I'll stay a little while.
Thank you so much. So next we have 5 panel talks touching on different areas of embodied intelligence. So first, I'd like